Helicopter Flying Handbook 6.1 Weight and Balance. Let's delve into a crucial aspect of helicopter aviation: the weight and balance considerations. Understanding and adhering to weight and balance limits are paramount for the safe and efficient operation of helicopters. Let's embark on this journey by exploring the significance of weight in helicopter operations. Weight, in the context of helicopters, extends beyond the simple measure of mass. It encompasses the combined load of the basic helicopter, its crew, passengers, cargo, and fuel. The intricacies of weight become apparent when we acknowledge that the effective weight, our load factor, can vary during different flight maneuvers. This is a key factor in our considerations today. Now, the starting point for weight computations is the basic empty weight. This includes the standard helicopter weight, optional equipment, unusable fuel, and all operating fluids. It's the foundation upon which we build our understanding of the helicopter's capabilities. And let's not forget the nuances. Some helicopters use the term licensed empty weight, which excludes full engine and transmission oil. Moving on, the maximum gross weight is the upper threshold we must be mindful of. Most helicopters have internal and external maximum gross weights, each with its unique implications. External loads, like cargo, can significantly alter the dynamics, especially when attached at various points. It's like a puzzle, where the placement of each piece affects the overall picture. Weight limitations are not arbitrary. They are the safeguards for structural integrity, predictable performance, and controllability. A pilot should never intentionally exceed these load limits. Operating below the minimum weight is not without consequences, affecting the handling characteristics and autorotational capabilities. Conversely, surpassing the maximum weight could lead to structural deformation or failure, particularly in challenging conditions. But weight is only one part of the equation. Balance is equally crucial. The position of the weight, specifically the center of gravity, CG, plays a pivotal role in helicopter performance. The pilot must ensure that the helicopter is properly balanced within its allowable CG range. This is not a mere technicality. Loading outside approved limits can result in insufficient control travel, jeopardizing safe operation. Visualize the helicopter as a pendulum suspended from the rotor. Changing the CG alters the angle at which the aircraft hangs from the rotor. A forward CG, for instance, can occur when a heavy pilot and passenger take off without proper ballast. This condition, evident in a nose-low attitude during hover, demands immediate attention. Conversely, an aft CG, a situation where the helicopter exhibits a tail-low attitude, can arise without proper ballast. This becomes critical during a vertical takeoff, and the consequences escalate if flight is continued. Excessive forward displacement of the cyclic control becomes necessary, affecting control authority and airspeed range. In conclusion, weight and balance considerations are not mere technicalities. They are the threads that weave the fabric of safe and efficient helicopter operations. It's not just about numbers, it's about understanding the intricacies that ensure the delicate dance of a helicopter through the skies remains harmonious and, above all, safe. Now, let's further enrich our understanding by exploring the nuances of lateral balance and delving into the practicalities of weight and balance calculations. In the realm of lateral balance, smaller helicopters generally don't necessitate a meticulous determination of lateral center of gravity, CG, for routine flight instruction or passenger flights. The inherent narrowness of helicopter cabins and the centralized location of optional equipment usually mitigate lateral balance concerns. However, specific helicopter manuals may prescribe the seat from which a pilot should conduct solo flights, highlighting the significance of maintaining lateral equilibrium. Unusual situations, such as a heavy pilot and a full load of fuel on one side, warrant attention, and the position should be cross-checked against the CG envelope. In the intricate dance of lateral balance, external loads play a significant role. Carrying loads in positions requiring substantial lateral cyclic control displacement can dramatically limit fore and aft cyclic effectiveness. Manufacturers anticipate these lateral CG displacements by strategically locating external attachment points, a fine balance achieved through design. Moving on to weight and balance calculations, we encounter two pivotal questions. First, is the gross weight within or equal to the maximum allowable gross weight? This involves summing the weights of the useful load components, pilot, passengers, fuel, oil, cargo, and baggage, to the basic empty weight and ensuring it stays within the permissible limits. Secondly, we grapple with the lateral dimension, focusing on the CG. It's not merely a numerical exercise. The accuracy of these computations is contingent on reliable information. A prudent approach involves querying passengers about their weight, adding a buffer for clothing, especially in winter. Baggage should ideally be weighed, but if a scale is unavailable, personal loading values based on individual estimates are acceptable. The concept of a reference datum emerges as a critical aspect of balance determination. This datum, an imaginary vertical plane or point fixed along the longitudinal axis of the helicopter, serves as the starting point for measuring all horizontal distances concerning weight and balance. It's a foundational reference, with its location determined by the manufacturer, offering a standardized framework for accurate computations. This knowledge is not just a theoretical exercise, it's a practical tool, essential for every pilot navigating the skies.